Here we go. Thanks very much. My name's Andrew Bogue. I'm from Catalyst IT. Thanks for giving me the opportunity, OpenStack Summit, to talk about a project we've been involved in recently, sort of taking some data warehouse techniques to Ceilometer. Now, this has been really interesting for me personally, and has sort of one of those fun projects where you've got to sort of mess around with various open source technologies and actually have some quite good results, where you can concentrate on sort of building things and delivering value, and not sort of on huge amounts of development, which is cool. It's sort of what one of the really great, powerful aspects of open source technology is that you don't necessarily have to buy expensive tools and make decisions about what you want to use, and you can sort of play with things and assess them. So just a little bit about us. Catalyst IT, we run our own public cloud in New Zealand, but we're a global business, our own public OpenStack cloud, and we're all about open source technologies. Here's some of the tools we work with: Moodle, Mahara, Drupal, Alfresco, Linux, of course, OpenStack. We believe open source technologies give us the best tool set to solve the needs of our clients, and to build the products that allow us to grow. So just in terms of this project, where we sort of began, we began with, we had an existing relationship with the NeCTAR research cloud here in Australia, great bunch of individuals, a large research OpenStack cloud based here in Australia, and we'd done one or two engagements for them with some OpenStack consulting. And we'd sort of talked to them about this, the amount of data they have and some ideas they had around visualizing that data and doing things with it. So there was sort of, there was the research cloud, there was lots of data, there was some questions about the data, and there was a bit of an appetite for an adventure, and there was a hungry, there was a bit of a vehemently ideological, grasp of open source technologies as part of the solution. So data warehousing. Now, I'm not I'm a data warehouse expert by any way, shape or form. I've had the great benefit of working with people who've come from a really traditional data warehousing background, and I've done what many of you do in the instance of requiring new knowledge. I've read books and sort of fished around online. So, when I used to hear data warehousing, I sort of thought, oh, that's that difficult thing where the people come into the room and they're really difficult and they want to do things and they sort of make everyone's life harder, was my perception of it, as someone who's sort of been involved in infrastructure and development. And, so isn't that just so here's some myths, about data warehousing. Isn't that the old way of doing things for, antisocial people with beards? I've got a beard, I'm reasonably social. And it isn't no SQL. Obviously, over the last 5 to 10 years, there's been a bit of anything that's not SQL-based solutions for large amounts of data sort of seem a bit incorrect, and everyone's all about, no SQL solutions for very valid reasons, but data warehousing doesn't require expensive proprietary warehouse solutions. You can use open source commodity databases pretty well. They do have their limits, of course, but MySQL or Postgres are, pretty powerful. And this sort of thing about relational database systems don't scale, right? We've all sort of heard that said, we've said it ourselves. The truth is that an operational database, and this is one of the things in data warehousing, they very much differentiate, because it's not a new thing, they very much differentiate a reporting database and an operational database in the way that you build it and the things that you use it for. And relational databases that are modeling operational parts of applications, with all sorts of joins and that adhere to third form normalization, as they taught me at university, they do have some real scaling problems, right? Like it's everyone's seen what happens when you get a very busy application that's got all sorts of tables and huge amounts of joins, and yes, that has some challenges with scaling, but that's not the same as what we're talking about here when you build the table structure in a way that means that doesn't happen. I'm using star schemas and dimension tables, which I'll talk about a wee bit. So data warehousing, here's a definition I sort of like. A data warehouse is a system used for reporting and data analysis and is considered a core component of business intelligence. Hey presto. So moving forward, as it pertains to OpenStack and this particular project, so most of the data that we wanted was in Ceilometer. Well, came from Ceilometer, was available in Ceilometer. So we wanted to get the data in a decoupled way. So we don't want to actually be in the guts of OpenStack to be doing this. We just want to be able to get the data out of OpenStack. So obviously using APIs where possible, and getting events and audit messages from the Ceilometer queues essentially. There was also some project metadata that we needed that was relevant to NeCTAR, which essentially is aligned with what an OpenStack project or tenant is. It's using, so you have extra things I talk about in my next slide called an Australian FOR, field of research. So if the slides will be up so you can look at that. It's essentially a standard classification system that you put with a piece of academic research, and there's a 6-digit code system that's been determined to mean certain things. It's hierarchical. I hope that sort of makes sense. The first, all the 09 are engineering, and it goes deep down 3 levels. It's sort of the same way as a Dewey Decimal System does, I suppose, if you remember those from libraries. But that's the standard in Australia. And each tenant in the NeCTAR OpenStack cloud or project has an Australian FOR, right? So that means they want to be able to ask questions about, how much of our compute is being used by engineering. Those sorts of questions is one of the things that the business of NeCTAR wanted to be able to see, and it wasn't very easy to pull that information out based on what they had. So yeah, most of our stuff, so that data comes out reasonably straightforward via an API. It's sort of a one-off deal. I mean, things do change around projects and tenants, but you haven't got 50,000 new tenants a day, obviously. So the Ceilometer queue, this was quite an interesting part of the problem. So we get the data from Ceilometer by integrating with the existing functionality of the latest version of Ceilometer, which I think is Mitaka, in running here. And basically we just add a couple of queues, a couple of RabbitMQ queues that Ceilometer just posts the data to, right? Now, that means that all we need to do from the operational OpenStack team is say, please guys, just make sure the stuff's written to a queue, and then you don't have to worry about anything else. And we were very cautious about not putting more operational overhead on the existing team. We don't want this to hurt their upgrades or have them to run another system. And it's actually quite a busy system in the sense that there's 3 queues for Ceilometer. There was another one, info notifications, I think. But the 2 queues that we were very much looking at was event sample, which had some audit messages. And I will admit to not understanding all the messages that are in the Ceilometer queue, and it will vary, I understand, but we very much sort of went looking for what we were looking for and sort of fished around, did a fair amount of analysis, but if we didn't need something, then we don't sort of try and necessarily reverse engineer it. So event sample had some audit messages, essentially about a compute node running within a 1-hour period, which we take, we throw away the rest of it. But there were 10,000 messages an hour from event sample, about 40 megs worth in compressed, because we compress it in JZip, big piles of JSON essentially. So yeah, Ceilometer puts on a piece of JSON which has a payload of information in it, right? And that goes onto a queue and we just pull it off. Metering sample, on the other hand, is a lot busier. It has all sorts of stuff about metering events like CPU usage, disk usage, network usage, as well as other things. That there's about 200,000 JSON packages an hour, and each one of those has multiple pieces of information in it. So it could have up to 20 actual payloads of metrics. So there's quite a lot going on. If in uncompressed form, it's about 4 gigabytes an hour coming through, but we compress it into JZip. So it's quite a bit going on, and we ran into an interesting problem as part of this, is that because queue-based integration is really handy in that you don't have to worry if the queue overflows, right? Ceilometer just keeps posting and maybe some packets go missing, but that's fine. We understood that might happen. Nothing breaks, no one gets in trouble, no alerts go off. It's just, hey, we've lost some data. That's okay, we understood that. And that happened when things jammed. But we actually discovered a week or 2 ago that as much as we were purging the queue a lot, pretty much constantly, for metering sample, we weren't always getting to the bottom of it, and some of it was still falling off. So I thought there was actually getting more like about 120,000 messages or 120,000 messages a minute, but it turns out there were more like 170, 180, and we just weren't getting to the bottom of the queue. Now, it wasn't actually that disastrous because we were aggregating all of these things anyway, so you were still getting a good distribution of all the metering messages. So losing probably 15 to 20% of the messages didn't break any of our analytics, but it was an interesting thing to bear in mind, is that we have to make sure that we're getting to the bottom of the queue. So we changed things and did some old school threading and forking in our Python script. It's a very simple set of Python scripts. It's a screen and a half that just connects to the queue, pulls it off, writes it to disk. Simple, right? So it's sort of like another queue in many ways. We just wanted to keep it nice and simple because that actually allowed us to do that straight away at the beginning of the project and then worry about how we were going to do ETLs and process it later, because once the data's gone, it's gone. So we've still got a couple more months we haven't actually ingested what we're in the process of now. So then we go on to this thing called Pentaho Kettle, or data integration. Now, who here's had anything to do with ETL tools? Okay, so I hadn't had much to do with ETL tools. I'm a sort of developer by background, although I don't do terribly much now. And when you saw the sorts of problems that ETL tools were sort of thrown at, you just thought, hey, I'd write a script for that, right? But Pentaho Kettle is an open source project. It's written in Java. It allows you to divide. It allows you to define things visually, which is sort of the idea, and you can not decode. Now I'm going to try and do a demo. So let's see if this works. Okay. So I'll talk you through this as we go. So this is a demo of, this is a recording of the ETL tool running on my desktop, on my workstation. And the idea, and when you run it on a server, obviously you don't get this input, but you can see, it just gives you a bit of an idea about what we like about it, essentially. So this is, there's no sound, so you're not missing anything. So as you can see laid out here, these are all the steps that do all the work, right? They do things like extract JSON, crunch JSON into pieces, pull data out of JSON, some conditional stuff, okay? And you sort of get the idea. It goes off into forks. That actually gets saved. So now I'm going to play it. This is just running on my actual laptop here. So it's only running on a subset of the values, and this is just me giving it some data to work with. So here it's playing, and the really cool thing is that down the bottom, as you can see in the bottom half of the screen, actually I'm focusing on a particular step here, and you can see that it's showing me some feedback about how fast it's processing, how many messages per second and all that, which is great because you can focus on, you can see the bottlenecks. Once again, this is all of the steps in the transformation, and the cool thing, they all run in parallel as well. It's not sequential one thing after this, so they're all running in parallel, which is the way ETL tools work. So it's sort of a bit like functional programming in some ways. But what this allows you to do, and it runs much faster on a server, is it allows you to easily see which the slow pits are, so you can optimize. It's a really good feedback cycle. If you did what we've done here with a script, which you could do, it would be a mess, right? Like, it doesn't matter which framework you use, doesn't matter how, eventually it would just turn into a mess. Like, there's too much going on, right? And it would just fall into that horrible world of unmaintainability. So it's a great tool, which is free and open source. There's a bit of a learning curve, but that's sort of the way things go. So one demo, I've actually got pretty crazy ideas about demos. Sorry. So yeah, just a bit, jumping around a wee bit, the whole idea of the real strength of data warehousing and putting is this idea of star schemas, right? I mean, so you have a table, you have a database table, and you have a fact table in the middle, which is just basically referential to dimension tables outside. So there's only ever one join that's going out. Everything's indexed to bejesus, and you add, and you put some metrics in there. Now, this seems like a pretty straightforward way to do things, but one of the really cool things that you do in data warehousing and star schemas is even things like dates are dimensions, right? So you have a dimension for a date, right? Now that seems like silly. Why don't you just use a database date field? But the advantage to that is that and one of the things that really gives you performance advantages over operational databases which don't do that is you don't have to do data arithmetic, right? So you're only ever talking about indexed values, which it just makes so many things really handy, and you can do all sorts of smart stuff. So the dim date, for example, is just a row of 33,000 values, which is like 20 years back and 20 years future, every single day in it, and you pre-calculate all of the short name days of the week, the long name days of the week, whether it's a weekday, whether it's weekend, potentially whether it's a school holiday, what quarter of the year it is, all that sort of stuff, so that whenever you're doing any kind of questions that involve temporal questions, you're just using like an integer that's been indexed, right? Now, that's that is a game changer in terms of your way to do any kind of time-based searches. And we do the same thing for hours, actually, in our case. So there's a dimension hour as well, right? So that's how we break everything up into hour-based chunks. So it works really well. And I'll give you an example. Once again, another ambitious demo. So this is our database server running, right? Like, so it's just running MySQL. It's a reasonably hefty MySQL. Like, it's got about 60 gigs of RAM, I think, but it's running inside the. You see that? Yeah. Okay. So we go to. This is just logging into the database table itself. So if I show you. This is production, although we're not, there's no danger here we're not anywhere near actual production data. I mean, sort of impacting production, because this has all just been extracted. So you can see, I mean, here's the fact tables. So some of the fact tables have got about 13 million rows. That's essentially, I think it's a bit under 2 months worth of data. So let's do a nice little aggregated. This is a view. I made the view. This is select on real-time data of a day's worth of aggregated calculations, right? So here we go. This is 1 day. So that's 1 day's worth of data. That was just calculated from obviously on the fly, and we've done some aggregations in there. So average CPU, minimum CPU. And maximum CPU, you can some of them do have these massive 1500% CPUs. That's what Ceilometer says. I suspect it's because of some HPC that gets a bit confused. It should only go up to 100, but that's what Ceilometer tells us. But it's doing. I mean, you can see there's the running count. There's about 6,000 VMs running, 6,000 compute nodes running, and there's about 25,000 vCPU count. So if you've got 6 CPUs, then it's multiplied by. That's the metric that comes out of Horizon anything. So that's not bad. 1.3 seconds for a whole day's worth of data. And you can pretty much get this. At the moment, there's about a 2-hour latency, but that's not because there has to be a 2-hour latency. You'd be able to get this down to probably about 15 minutes without too much trouble. And the data and the capacity of this database is, I mean, like I say, it's just a MySQL server running on Ubuntu. At the moment, it's using about 20 gigs worth of site data for the storage, and it's got about 50 gigs of RAM. And once the storage goes over that, then it will start performing a lot less spectacularly. But we can just give it more RAM, and that will probably be about 4 or 5 months worth of data. And then you've got the option of cutting things out or just putting it on a bigger VM, right? So it's all reasonably commodity, but does a pretty good job. And what we actually use these fact tables to then go and build reporting tables is the way that we go. Oops, I don't know how to make it go back to where I was, but anyway. So Pentaho Kettle Star Schema, dim date, why it's cool. And here's the other tool that we used. It looks like I've got time. I'm not sure. I might have to just pause before my third demo because something's going to go wrong. But so we wanted to deliver a visual interface, obviously, of this data. The idea is they have some sort of analytics or reporting tool. So we sort of fished around, and we really didn't want to get distracted by building dashboards in, the latest framework of JavaScript, whatever, because that tends to be all really so easy until it's sort of not, and you just get distracted, right? Like it's just not. You get caught up in these little things that become big things. I mean, obviously, there's so many really cool tools, and if you are the right flavor of rockstar front-end developer, these things all get solved. But that wasn't really the sort of the physical muscle that we were applying to the problem here. So I just sort of didn't want to go down that journey. And we looked around. Obviously, there's as-a-service offerings. There's proprietary tools like Tableau, which is incredibly awesome, but it's very not open source. Pentaho's got an offering as well. The Pentaho ATL Kettle thing is only part of their suite, but we tried it. It wasn't really for us. So this other one, I mean, I don't know if anyone's heard of this thing called Superset, or Caravel it used to be called. It's an open source reporting engine that comes from none other than Airbnb. So they let this thing out. It's a pretty healthy open source project, getting lots of commits. We'd looked at it before, so a year or two ago, but we couldn't get it working. I mean, we sort of stood it up, but it was just a bit fragile. And even now, it's still a bit I mean, it's still a bit fragile. In fact, well, but saying that, I mean, it's very good. So I can give you a bit of a demonstration here. Now, this is a basic demonstration. I have to apologise because this dashboard is based on, I mean, I basically broke it earlier today. So I had to actually rebuild it. Well, the dashboard was easier to do, but the importing of the data source was a bit more of a wrestling match. So this is Superset, okay? Now, what you're looking at here, so it's a reporting engine, and it allows you to, make custom reports of all the ones you would sort of imagine, line graphs and bar graphs and all that sort of stuff. But none of this required any coding, right? The only thing you have to do here is define, so you find data sources. So you have to find a database that sort of reads all the standard kinds of databases you can imagine. Although it was a bit better with Postgres than with MySQL, actually. And then you give it a source, right? Which is a table essentially, which is what I've done here, aggregated daily activity. So this aggregated daily activity is being built from the fact tables. It takes about 2 minutes to build, and then it gives you everything in a nice one singular table that's all been indexed. It's got about 10 days worth of data in it at the moment. So there's a little bit of latency of the reporting, but these things are all aggregated anyway, right? This is not a real-time. The real-time reporting solution is not the solution we're trying to solve here. So I'll just show you this reporting table we've got here. So here we've got a nice little line graph. These represent availability zones in the cloud. And this is all real-time data. This is all from about 2 or 3 hours ago. And this represents also availability zones per day. And what we're seeing here is vCPU hours. Now let's go and ask ourselves the question, how about if we want to look at a particular project? That's a tenant. So we just choose one of these here, away we go, and then we'll see different things. Generally projects are in one availability zone, so that makes it not terribly exciting. So I want to get rid of this. And let's say, well, what about a particular field of study, right? So this is the fours that I told you. So let's look at chemical sciences, for example. Here we go, and we can choose a couple if we want, psychiatry and cognitive sciences, and away we go, right? Various sort of line graphs here. Some of them are doing more high average CPU than others. This sunburst thing is actually quite a cool thing. I'd never seen these before. So this is sort of like a 3-phase pie chart. So you can sort of see we start at the bottom level, and then we move to the second level, and then we go to the third level. So yeah, it's quite a nifty. So it's quite suitable for the FOR, given that there's 3 tiers. And here's that same thing as up before. So it shows you the usage broken down, a bar graph broken down into various AZs. And look, this is a pretty unspectacular dashboard. The point is, I mean, I did this dashboard 35 minutes ago, right? So there was nothing, and I did the super. So it's pretty easy, and it's all open source. And I'll show you some of the other stuff. Here's some of the ones that come with Superset. So there's a data set that comes with it, and here's World Bank's data. You can sort of see here's your sunburst again, and this is population. What is this World Bank data? I think this is population data. Yeah, population data. So these tree maps quite cool. You can sort of let's break it down to Europe and Central Asia. You got your filterability. You sort of need to, from my perspective here, is that you need to. Actually, no, that won't work because it's not conditional. It sort of makes sense to be putting stuff into reporting aggregated tables, I think. I mean, you can do it other ways. Like you can make views, and there is like an SQL engine over here on the side, but you sort of want to be making really polished indexed reporting tables, I think, because it's just going to make it work much better. It's just going to be snappy, You don't want it to be waiting because yeah. So anyway, so that's one of them. There's another one here. I'm getting close to the end there. World Bank data miscellaneous charts. Just sort of showing some of the other things they can do. I don't even understand really how that one works, but looks pretty cool. This calendar heat map is interesting. I can sort of think of some use cases for that. But there's a pretty broad spectrum of possible graphs, right, is the point here, right? So, plenty to do all sorts of cool stuff. Like there's some geo smarts and that, like it understands, like obviously Airbnb would be using this to plot stuff happening in physical locations and all that. So, basic pie graphs, all your stuff, bar graphs. It's pretty easy to wrestle this sort of stuff up, pivot tables, some line graphs, la-di-la. And you can click on any of them and sort of say explore and, adjust them and Oh, that's spectacular end. Okay, so that's the demo, and that's demo number 3. Sorry, high five myself on that one. So that's pretty much the end as well, which is good. Actually, I can just go to the end here. So yeah, so there's my dim date. So Superset, aka Caravel, and look, I want to reference the books that I read about data warehousing, Ralph Kimball, The Data Warehouse Toolkit, number 3. If you've got any interest in it, read that book. It really does. It's eye-opening. It's awesome. I think I got the 2nd edition, but 3rd edition, really, really good. And not particularly technology agnostic. It's not particularly focused on big enterprise, horrible tools. And there's plenty of books around Pentaho Kettle. It's called Pentaho Data Integration and Pentaho Kettle. So just bear that in mind. And Hitachi just bought Pentaho. It takes a bit of getting used to. There's some real gotchas around the way it works with repositories. I was using it completely wrong for about the first 3 months because I didn't know how to do some things, and I was doing all this really weird stuff to try and get it working, and then I had this light bulb moment when I figured out how repositories work, and it's actually really easy to use in many ways. It's cool. It's really engaging. You can do a lot with a little bit of time, and you've just got to get your head around how it works. And it's, despite it being Java, every now and again it just doesn't load. I mean, it just sits there and thinks on my laptop, and then like a pop-up screen comes up or something. But anyway, that's it. So made it, and might have any questions. Anyone's got any questions? I mean, we're going to open source this once it's in a bit more shape. It's still a little bit rough and ready. I'd like to have this a bit more polished, and hopefully things like the ability to do the ETL will be useful for everyone. I have a suspicion that I'm not an expert on Ceilometer, but I have a suspicion that people's Ceilometers will be different, and that might be something that has an impact. But all the same, I mean, it's sort of, at the very least, it proves that it's viable. I mean, we're currently dealing with like about 200,000 messages an hour with no real particular level of concurrency, not trying to parallelize things in a special way, and it's keeping up easily. So, we could go double or triple the size, and we'd still just be able to have basically a batch job running and ingesting all these things, and yes, we could run things in parallel. That would be doable, but that just wasn't a problem we needed to solve to begin with. And once the transformation gets going, it sort of cranks pretty well anyway. Yeah.
I got about 3 questions. One, you said so you haven't run into any problems with RabbitMQ for your messaging bus overflowing with the number of messages?
So we have, yeah, we have.
So what actually had happened?
So nothing. I mean, the problem is you lose data. Other than that, Ceilometer doesn't get upset. Ceilometer just writes to a queue.
So is your message bus separate then from other services? Like your message bus basically, like Nova and Neutron aren't using the same messaging bus as your Ceilometer messaging bus?
I don't know, to be honest. It's just using the RabbitMQ that NeCTAR provided us. But I mean, the whole point of queue-based integration is that you should be able to overflow it, and you define how much memory you want to give it and how much space you want to give it, and if people write more than that, then it overflows and nothing happens. I mean, you lose the data, right? But it doesn't break. They were quite cautious about what the capacity of it was. Like, we had to up that. Like, at the first it was only 100,000, which wasn't quite enough, because you do actually want to be able to handle turning the things off for like an hour or something. And we've recently pushed that up to 500,000. And we sort of every now and again have a look to see if stuff's falling off the top. But if it does, it does. Like, it doesn't. It's not a disaster. But we do need to be paying attention. I mean, and look, there's all sorts of ways in which this could be improved, and if it was a bit more enterprise, you would want to, have sort of monitoring and actually be detecting if there were regularly overflow events and all that. But I mean, we just sort of turn up the volume, and that's cool because there's always this project has been really cool, but it's so easy to go down a rabbit hole in so many directions, and we just tried to keep it on a vaguely working solution, which wasn't the case for quite a lot of it, to be honest.
The other question I had was, like, what kind of, like, has there been a very significant insight that you've been able to pull out of the Ceilometer data that you've collected?
Yeah, I think that some of them are starting to happen is that we can see, for example, that I mean, this was something that they suspected that was happening, but they weren't able to prove it. That there was some people, some researchers, because NeCTAR doesn't charge for the uses of the cloud, right? They sort of give people quotas because they're researchers and scientists. And there was a suspicion that people were hoarding large VMs because you can't always press a button and actually get the large VMs. It depends on capability, you know, the capacity being in a particular server host that can host like a 64 or whatever their biggest ones are. They got some big options. So they were suspicious people were hoarding them. So they can see that, for example, there's a compute node that's been running for a long period of time that has consistently extremely low memory usage and extremely low CPU, right? So they can sort of actually say, well, guys, come on, you know, like you need to learn how to use orchestration tools and all that and use it when you use it, but you shouldn't be running a 64, you know, CPU VM and it not be doing anything. So those sorts of insights, they want to have, I mean, it's, you know, obviously it descends into the world of sort of academia and the politics herein, but that was actually something they wanted to, that some of the business wanted to know about at the beginning of it. But there are some other things. I think it'd be, one of the other things I'd like to include is potentially using it as a way to try and educate or provide feedback to the users of the cloud to use it in a more cloudy way, not just use it like VMware. You know, like actually use auto scaling techniques and turn things on and turn things off, and you know those sorts of things, which I don't think everyone's doing. Number 3.
I guess I was just curious about the interval you guys were collecting that data at.
The interval from Ceilometer.
Yeah, is that like the default interval, maybe 600 seconds, or sorry, 600
So that Ceilometer is writing to the RabbitMQ. I don't know actually. It's pretty much constant though, I think, because it's certainly low because we're polling the queue. We just changed this last week actually. We're polling the queue basically consistently on 3 threads, and it's sort of always got something on it, and then and we empty it.
There could be jitter in the polling agents.
Yeah, I'm sure there is. Yeah, I mean that's taken care of. That was taken care of by the OpenStack operational team. But all they needed to do was basically put a new endpoint into a configuration file in Ceilometer, so it was really easy for them. We didn't have to write at the beginning we thought we might have to write like a Ceilometer plugin or something, but with newer versions of OpenStack, I think it's Mitaka, you just basically you just tell it to write to a queue. So I don't know how much more configuration it was required, but we're not really fussed on any of the latency because it pretty much comes as close to real time as you sort of need. And if we needed to get closer to real time, we could start, you know, decoupling things tighter, you know, which I don't really like the idea of because I just think it'll break it. If we start feeding, you know, messages straight into a Java API or something, I mean, I don't know, I just think that will start getting more fragile. The great thing about queues is that they deal, one of the great things with queues is they happily deal with load spikes, right? So, and if you know what your average is, which is like I say, about 200,000 an hour, and that's the maximum. It never goes like considerably over that. And even if it did, we could hammer it. It doesn't go to like 700,000 an hour. So you just, even if it fills up a wee bit, you know, you just constantly work it down, and that's the strength of queue-based architecture, right? Cool. Thank you very much. Thanks a lot.